Okay, hi guys. I'm on week 8, task 1, which is me explaining PowerPoint day 4. And you should have an example of the PowerPoint. We're still talking about chemical reactions. Today, we're going to learn that there are 5 types of reactions, and I'm going to explain the first 2 types. And then later in the videos, I think it's task 5 or something, I'll explain the other types. Okay, so when you got your PowerPoints, you should see these. So it says after today, you're going to learn synthesis and decomposition reactions, and you're going to learn to predict the products for these reactions. Just so you know, there's 5 types of chemical reactions. We have synthesis, decomposition, single replacement, double replacement, and combustion. You're going to learn a little bit about all of these. Mostly at the end of this unit, I want to be able to give you a compound or a couple of compounds, and then you're going to tell me, you're going to predict the products. So if those 2 things chemically reacted in a chemical reaction, what would the products be? So that's the end goal of this week. By the end of the week, you should be able to do that. Predicting products. So let's talk about synthesis. So I'm not going to hold this up anymore. I'm going to do some writing down here. So when you look at synthesis reactions, this is type 1. Well, the first type of reaction, okay? Synthesis. And this is all in your notes. I'm just going to talk it out so you know. Synthesis is when 2 elements combine to make a compound. So, it goes like this. You're going to get element. I'm trying to write big so you can see it. Element plus element yields a compound. So, or we often say A plus B yields AB, where these are stuck together in a compound form. Okay? So this just means I can give you a metal and a non-metal, and they chemically react, and you get a compound. So a couple examples of those. Easy one, right in my head, I always do it. It's sodium plus chloride gives us sodium chloride. Most popular chemical on earth, right? It's salt. And so this is an example of A plus B yields C. When you're doing these plus things, you need to know their charges. So in my head, to form this, I know sodium is a +1, chlorine's a -1. I did a crisscross and I got NaCl. I knew that, but I did these charges in my head to get this product. Part of predicting products is you're going to have to know when these 2 come together that they are chemically combining and they're using their ionic form, and which has charges, and then you'll get this. So let's do another one of these. A plus B yields AB. So what if I did, I'll write out the words, magnesium plus phosphorus yields magnesium phosphide. This is one, A plus B yields AB. And you guys, this is all in these slides, but just so I can explain it to you a bit better, which is what I'm up to today. I'm just trying to find my periodic table. Sorry, I got it. Here we go. When we look at magnesium, we know it's a +2. When it's about to combine with phosphorus, it's a -3. So we would have, the formula would look like this. Magnesium plus phosphorus yields Mg3P2, because we crisscrossed and we got magnesium phosphide. Magnesium plus phosphorus yields magnesium phosphide. Metal plus non-metal yields this compound. A plus B yields AB. Okay? So you have to know what's going to happen in this section or unit, whatever you'd like to call it. I'm going to give you 2 things. I'm going to ask you to predict the product. So synthesis is really easy. It's kind of what you've done before. This element plus this element yields this compound. Okay, I'll do another example that was on the slide. Sulfur plus aluminum. Making sure you can see this. Sulfur. Aluminum yields aluminum sulfide. So the metal always goes first. Aluminum, sorry, I'll turn my phone off. Aluminum. It always reads metal, non-metal. So sulfur plus aluminum. Sulfur is an S. You just look that up on the periodic table. Aluminum is Al. Yields, well, what does aluminum sulfide look like? Well, we got to use our ions for this. This wrote it in this order, but that doesn't matter. They wrote the non-metal first. That doesn't matter. We know it goes metal, non-metal. So aluminum is the metal. We know you get a +3 for aluminum. For sulfur, sulfide is a -2. You just look those up in the periodic table. What does aluminum sulfide look like? Al2S3. So sulfur plus aluminum yields Al2S3, aluminum sulfide. That's the answer to this. You get metal and a non-metal. They've reversed the order, but it's just words. It doesn't matter. Sulfur plus aluminum gives me aluminum sulfide. Metal and a non-metal, A plus B gives us AB. Okay, so those are the examples of something called synthesis, where you can see two things have been synthesized or put together or mushed together. That's the case. Okay, the second type of reaction you're going to learn about today is called decomposition. And if something decomposes, what do you think happens? Well, decomposition means it breaks down. So it was together and it's broken down. So it can be compound is going to yield element plus element, or it can just be element plus a simpler compound. It doesn't always element, but it's easier to just, in the simplifying learning of this new way, we're going to say its compound breaks apart into its elements. So it's AB yields A plus B. So it's the opposite of synthesis. These guys get broken apart. Okay? So let's look at this example. Super easy one. I've got potassium, nitride, nitride, T-R-I-D-E. There I go. Potassium nitride. What does that break into? Well, it breaks into potassium and nitrogen. Remembering, it goes back to its nitrogen form, not nitride. Nitride is when it's an ion, right? Nitride is when it's an ion. When it's just here in the elements, when it's back to just being an element, it's not charged, and its name is nitrogen. Okay? So remember that. So what does it look like in the chemical formula? What's potassium? Potassium's K. Nitrogen is N. Well, the K, this is a little scrap work down here. Potassiums are +1s. Nitrides, look at back here, they're -3s. So what does potassium nitride look like? K3N. K3N yields K plus N. And then eventually you would balance this equation, right? You'd be like, oh, there's 3 potassiums on each side. Boom, now we're balanced. Okay, that's getting a little ahead of ourselves, but this is what a decomposition looks like when something is broken apart. Okay? Okay. So, that is one example. And there's a couple little special examples here that if we were in class, I would have you studying. And so, sometimes there are rules around decomposition. Okay? There's some rules around decomposition. So when I look here, this is a special one. So this is type 1. I'm going to show you right here. This is a metal chlorate. So this is when you have a chlorate. So here's the example of a special one. Metal chlorate always yields the metal chloride plus the oxygen. So this is a rule. I would have had you study this. Metal chlorate always yields the metal chloride plus the oxygen. So any metal, doesn't matter what metal, you could use any metal on the periodic table. plus a chlorate. Well, what does a chlorate look like? You guys know this. And if you don't, that's okay. Look here. Chlorate from your polyatomic sheet, it's a ClO3 and it's a -1 charge. That's what a chlorate is. So any metal plus the chlorate will give us metal chloride plus oxygen. Okay, so let's look. So let's look at barium chlorate is what they use. Barium chlorate. That's what they used in the example. Well, what does that look like? Well, we just looked up chlorate. It's ClO3 -1. So let's look up barium. Barium's right here. It's a +2. This is just some scrap work down here just to figure out what barium chlorate looks like. I did a crisscross. I got Ba, open the bracket, ClO3, close the bracket 2. So that's barium chlorate. I'm going to write it underneath it here. Ba, ClO3, close the bracket 2. Barium chlorate is going to yield the metal chloride plus oxygen. But what metal did we have? Well, barium's our metal here. So metal and the chloride. Well, that's easy. Metal is barium. We already looked it up. It's a +2. The chloride, it's Cl. Chloride, it's Cl -1. So what does the metal chloride look like here? BaCl2. So we're going to get barium chloride. And in this case, it's BaCl2 plus oxygen. Well, oxygen is O. But remember, something special about oxygen is it's one of our super 7. It's one of our super 7 that are diatomic elements, and they're never alone. That's special. Oxygen right there. So we got to put a 2 on it. So this is barium chlorate yields barium chloride plus oxygen. Here's what barium chlorate looks like. This is barium chloride plus oxygen. Then you balance it. I'm not going to do balancing on this because we learned that the last section. Okay? But this is predicting of products. If I give you a metal in the chlorate, ClO3, then you know it's always, whatever the metal is, doesn't matter. Could have been barium, could have been magnesium, could have been sodium, could have been lithium, doesn't matter. Plus the chloride, plus oxygen. So that's the first exceptional rule, or this is like a special way to predict products. These are like examples or special decompositions. So that's the first of the special decompositions. Here's the second of the special. There's actually 5 or 6 types that you would have to memorize if you were in level 1. I would have given you potentially kind of a cheat sheet in level 2 for this, but it's still where you have your notes in front of you. It's the same as a cheat sheet. So let's look at the second part. If I have a metal and a carbonate, I'm always going to get a metal oxide plus carbon dioxide. That's the rule I would have made you study. If you have a metal and a carbonate, any metal, doesn't matter the metal, carbonate, and carbonate, do you guys know what carbonate is? You'll see it right here. You see it on the sheet. Carbonate, can you see it? It's right here at the top. CO3 -2, carbonate. Any metal with a carbonate is going to give us the metal oxide plus carbon dioxide. That's a rule. So if you have a metal carbonate, this is how it's going to decompose every time. This is how it's going to break up. And so let's give an example that they had here. They gave us potassium carbonate. Is going to yield the metal plus the oxide. So we know the metal here is potassium. Potassium oxide plus carbon dioxide. That's the rules. So let's write that out. Let's do some scrap down here. And let's write this out in chemical formula. Potassium carbonate, what does that look like? Well, we know carbonate's CO3 -2, because we just looked that up on our polyatomic sheet. Okay, carbonate. And potassium, you look right here, it's a K+1. So if we crisscross, what does that look like? K2CO3. That is potassium carbonate. How does that break apart? If you saw that in a question, you said, how does this break apart? You'd go, oh wait, it's a metal and a carbonate. Every single time it goes metal oxide plus carbon dioxide. So the metal oxide. So the metal is potassium. Oxide, you know, is oxygen here. It's a -2. So you get K2O in this case as the metal oxide. K2O plus carbon dioxide, CO2. Carbon, this is a molecular, right? It's two nonmetals, carbon dioxide, di meaning two. So you use the name then. And then you would go ahead and balance that. Okay? This is the second special way that something breaks apart, a metal carbonate. And they gave you the example, potassium carbonate. Would not matter what metal I had. You would have to figure it out. Maybe it's a metal with a different charge, and that's okay. It doesn't matter. Okay, so that's the second special way things break up. Let's do the third special way things break up. There's, like I said, there's more intense ones. I think these get a little harder, but we're just going to do these three for us. So we've got a metal hydroxide. It yields a metal oxide plus water. So this is the third special rule. If you have a metal hydroxide, you're always getting whatever the metal was, oxide, so metal oxide plus water every time. So let's look. In this case, on the sheet they gave us tin 4 hydroxide, Hydroxide, and we have to guess. Well, we know it's tin 4 is the metal. Tin 4 oxide plus water. So let's write that out in formula. So scrap down here. So tin 4 hydroxide. Well, tin 4, you don't really have to look that up. Well, you might have to look it up because you might not know that tin is SN, but I do. But anyway, let's look it up for you. I don't even see it right here. Number 50, tin 4. So SN plus 4. Okay, hydroxide. That's on the polyatomic sheet right here. That's hydroxide. Where are you? OH right here. Hydroxide, -1. OH. Crisscross, what does tin 4 hydroxide look like? SN, open the bracket, OH, close the bracket, 4. So that's tin 4 hydroxide, SN, open the bracket, OH, close the bracket, 4. It's going to yield tin 4 oxide. Well, we know it's SN plus 4. Oxide, we look at our trusty periodic table. We know oxide is O minus 2. Crisscross tin 4 oxide, I get SN2O4. I have to yield that down a little bit because there's 2 and 4 of those. It's just like when you do fractions. So it really becomes SNO2 because they can both be divided by 2. So this is showing you a few things here. So tin 4 oxide is SNO2 plus water, and I write water HOH because then you can still see the hydroxides. It's easier way to write water. If you wrote H2O, I wouldn't mark you wrong. It's not wrong. I just find it's easier to see the hydroxides coming over in some types of balancing equations. In this way, you wouldn't be able to balance it that way anyway because there's no single hydrogen. But I always write HOH and get in the habit of HOH. But that's just me. So that's the third special way. Okay? 3 special ways that you're able to do this. All right, so that was the end of those PowerPoint for this day. So I'll put this out on there. And yeah, I'll do some of the practice worksheet problems with you in a second. Okay, bye-bye.